When I was younger, I used to think that operating headlights, rotary beacons, flashing lights, street lights, passenger car lights were all pretty cool to have on my model trains. As I got older, I realized I didn't like to operate my trains in the dark, so what did I need all that lighting for? Well, then I had kids, and they think the lighting is kind of cool. I'm also thinking about joining a model train club, and one of their rules is that all cars at the end of the train must have some sort of a light on them, so be a caboose or a passenger car, or some sort of a circuit in order for the last car of the train to be detected. So here's where I am on my passenger car, and I would like to use this potentially at a model train club. I also want something that would be interesting for my kids. So I'm considering adding some interior lighting for it. In order to do so, well, first of all, this is an old Varney kit, and once the sides are glued on, this thing is sealed. There's no taking the top or floor off to adjust the lighting. So I want some kind of lighting that doesn't burn out. And my option then would be the light emitting diode. So it's not an incandescent bulb that burns out. The LEDs will last many, many hours, probably outlast me. So I'm going to go ahead and install some of these in this passenger car. You can see this is a combine. So I'm going to put the lighting for these windows here. This is probably going to be a bathroom window. That's why I frosted it over. So I'm going to want some sort of a light block here because I don't want lights coming out the passenger car or the baggage car door. So in order to do that, I need to design a circuit to power the light. I bought a whole bunch of these warm white LEDs from China, but I use them for my headlights. So they look like this. They look like this. So it's a pretty small bulb. It's not as small or as narrow as that, not as narrow as that light strip, but that's what I'm going to use to light this thing. Now this coach probably wouldn't have had like really bright lights on it. It probably would have had 2 or 3 lights along the ceiling to kind of light it up. So I want a kind of a soft glow. And one thing I don't want is the light to be going through the car sides or leaking out cracks, because that would look terrible. So the one thing about these LEDs is they're very bright. So I need a way to dim them down. Well, one thing about the LEDs is you need a current limiting resistor. You need a current limiting resistor to keep from burning them up, because if you don't have the resistor, these things fry in millisecond. So if you're drawing electronic component diagram, this would be a resistor. So this restricts the current flow to the LEDs. Typical values resistance is measured in ohms. Your typical value that you might use would be about 1,000 or so ohms would be good to limit current to your LEDs. But the higher the resistance value, the dimmer your LEDs are going to be. So for my bright headlights, I might want a lower value of a resistor than I would for a passenger car light, where I want it to be a lot dimmer. So I'm going to have to experiment around with what size resistor to use. The other thing I want to do is I want to make sure that when this car goes over some dirty track that the lights don't flicker, because that would look terrible. So one way to keep it from flickering would be to use a capacitor, which is basically an electricity storage device. So capacitor component looks like this, and this would be an electrolytic capacitor, so it's polarized, and this would store electricity. So when the car loses track power, the capacitor will supply current to the LEDs, so that way they don't go completely out. The other thing about LEDs is they only work in one direction, so the current has to flow from one side to another. It's not like a incandescent bulb where if the polarity is reversed, it still works. So the polarity has to be a certain way for LEDs to work. So one way of rectifying the AC current or whatever polarity is on your rails to DC would be to use a series of diodes. And a diode component looks like this. And this side of the diode, where the straight line is called the cathode. And the part where the triangle is called the anode. And the anode is positive and the cathode is negative. If you remember back to your chemistry classes from high school or college, you would know that a cation is negative and an anion is positive. So the positive side is the anode, the negative side is the cathode. So current, if you apply a negative current to this side, it will flow. If you apply a negative current to this side, current will not flow in that direction. So an LED works the same way, except it emits light when the current flows across it. So these are the three basic components I'm going to use to design my circuit. So I actually went ahead and designed. Here is my circuit. It's a very simple circuit. It doesn't matter what polarity your track power is because I have 4 diodes in here, an arrangement called a bridge rectifier. If you notice, there's 4 diodes and the anode side connects to each other and the cathode side connects to each other. And so if you can imagine, if a negative current comes to here, it's going to flow this way to here. If the negative current is over here, it's going to flow this way to here. So it separates the charges where positive is on one side, negative is on the other side, no matter what your track polarity is. So downstream of that, I have an electrolytic capacitor. And this serves as an electric storage device, which will power these LEDs over here in the event that the track power gets interrupted. So normally you've got track power coming this way, powering the LEDs. This gets interrupted, the capacitor can take over, and for a few seconds power these LEDs. I also have my current limiting resistor in here, which will keep these LEDs from burning up, and will also serve to dim them a bit to get them just the right brightness that I need. So I did some playing around, and I built myself a circuit. This white thing, we call it a breadboard. So these are components that I had left over from years past when I used to do some building with electronics. So this breadboard, the way it works is these end pieces here, these are all connected together. This row of connectors at the end, this is all connected together. Same with the one on this side. And then each one of these columns here is also connected together on either side. So it's a way to kind of organize your components. Being that this is a small circuit, I can just, do things how it fits. But I have my LEDs over here, my current limiting resistor over here, my diodes which serve as the bridge rectifier, and my capacitor. So these leads come from the track power, so they come to here. They come to the bridge rectifier. So they come through here. So this would be, as you can see, there is the cathode side going to this row. You can't really see it because the capacitor is blocking it. They come to this row right in here. And the anode side, so this diode and this diode, come to this part right here. And then I have this capacitor, which connects between the anode and the cathode sides of this bridge rectifier, or of these diodes. And then I have my current limiting resistor, and I have my LEDs. I think I'm probably going to use 2 LEDs to power this passenger car, or because I don't want it to be too bright, and I could probably get what I need out of these two LEDs. I don't need more than that, but we'll see. So I'm going to connect this up to some power. This is my kind of crappy power supply here, made from an old Lifelike power pack, but it does the job. So I'm going to connect my power onto it, and I will turn it on. And my LEDs light. I turn it off, and they slowly dim as the capacitor takes over. I turn it the other way, and they light again, and they slowly dim again. Now watch as I disconnect the power. They're still slightly lit, so they're dimming, and they will serve to keep the lights lit when the car goes over dirty track. So the reason I laid this all out at first was to play around with different values of a resistor and different values of a capacitor. Too big of a capacitor, the lights stay on for too long. Too small of a capacitor, and the lights don't stay on for long enough, and you'll get a flicker. So I went through my drawer of capacitors, and there's various sizes. These are all electrolytic capacitors. There's various sizes. They are polarized, so it shows you which side connects to the negative current, and the other side will connect to the positive current. Capacitance is measured in farads, but a farad is a very large unit. So typically, your capacitor is going to be in microfarads. So this one is 33 microfarads, and the maximum operating voltage is 16 volts. So I'm going to want something that's can handle the voltage of my track. 16 volts, so kind of barely cut it. I might want something that could work for 25 volts or maybe even greater than that. But once the higher the voltage or the higher the capacitance, the bigger the capacitor is going to be. So I don't want something too big that's not going to fit in here. But I also want something big enough to where it will eliminate any flicker from the lights if the car goes over dirty track. So I played around with the different capacitance, and I settled on this 100 volt, 100 microfarad capacitor. That's the size that gives me that keeps the lights on for as long as I need them to be. And this is a resistor. I did the same thing. I went through my drawer of resistors here, and I played around with it until I found one that was the right value. So this is an old Radio Shack pack of resistors. Wish Radio Shack was still around, but unfortunately, I have to order all my components or salvage them from broken electronics. So in the back, it'll show you what the resistance value is. So there's a color code. So this particular one, the first color is purple, the middle color is green, the last color is orange. So the purple or violet, so that would be 7, 5. Is that purple or is that brown? I'm not very good with colors. I think that's brown. So this one is actually 1, and the green is 5, and then you multiply it by 1,000. So this is 15,000 ohms. So ohm is the unit for resistance. So this is a 15,000 ohm resistor and a 100 microfarad capacitor, and that's what I've decided I'm going to use to make my lighting circuit. The diodes that I'm using are just general rectifying diodes. I bought a whole bunch of them one time. They're really cheap, but this is the kind of diode you want to use. Ideally, I would have a bridge rectifier that I could use, but again, Radio Shack doesn't exist down the street anymore. So rather than order something, I'm going to use what I have. I wasn't going to show you guys me soldering because I don't want people to make fun of my soldering equipment or technique, but I'm using a very cheap Harbor Freight pencil soldering iron. As you can see here, I already melted the cord to it when it was brand new. This is just some cheap rosin core solder. Thin solder generally works best for electronic stuff. I have switched to using the lead-free solder. because it is safer. And this is my soldering holder, which is old Bank of America coffee cup without a handle. So I'm going to go ahead and assemble this all together. First step is going to make the bridge rectifier parts. I'm going to use this piece of an old computer ribbon cable. These are going to be my flexible wires that I'll eventually attach to the trucks. So I'm just going to go ahead and start building this thing. So there we go. There's the basic circuit. So I've got my bridge rectifier made from 4 diodes. I put some heat shrink tubing around it to kind of separate things a little bit. Then I added my filter capacitor on there, or my I guess my keep alive capacitor. I put my current limiting resistor on. With the heat shrink tubing, just kind of reduces the chances of having a short circuit later on. Also makes it look a little cleaner. Used to use a heat gun. Then I saw a guy using a big lighter. I decided that's a lot easier. a lot quicker. That's the way I do it now. So here's my circuit. I'm going to go ahead and unplug my soldering iron. I don't know how many times I've left it plugged in. And come back to find a ruined tip. We're going to test this thing out, or try to. Might work, might not work. But if you screw it up, it won't be that big of a screw up. Doesn't work, number one thing that I'm going to test, switch this LED around, because I don't remember which way they go. So where did my power pack go? Here. See it. These alligator clips might not clip very well onto this end wire. It is not lighting up. Do I have it plugged in? I do. Let's switch the leads on this LED. That should work then. Yeah, there we go. So I turned it on, turned it off. Capacitor slowly discharging. Perfect. And there you have it. There is my passenger car lighting circuit. I will install it. And my combine car. So I'll go ahead and I'm going to put this in the baggage compartment somewhere. Let me just stick it on with tape. Run the wires underneath to the trucks. And I am going to have a lit passenger car. And that will be kind of cool. Till next time.